Alright, so here we are with another example in the related rates section. This is kind of a classic. We have a street light, and the street light is mounted at the top of a 20-foot pole. A man 5 feet tall walks away from the pole with a speed of 5 meters per second along a straight path. How fast is the tip of the shadow moving when he is 30 feet from the pole? Street lights, 20 feet, man 5 feet tall, walks away from the pole. How do you get a shadow? How is a shadow constructed? So here's a hint. Start with a street light, then draw the man, and see if you can figure out where the shadow is coming from. Okay, so go ahead and pause the video, see if you can draw a picture, and then come back in a minute or two. Are you back? Let's go ahead and draw our, oops, let me get the pen going here. So here we have our street light, 20 feet tall, and here we have our person. It's probably not to scale. I better draw him a little bit bigger. I'm gonna have some trouble there. Okay. So where's the shadow coming from? It's coming from the light, right? That's going right off the top of his head and then shining down on the ground. Oops. Maybe we draw that. Good. Okay, and so what you're supposed to see here is that we have some right triangles going on here, right? Good. All right, so now once we have this picture, we want to think about what should we label as constant and what should we label as our variables. So let's go ahead and look for our constants first. The street light's mounted at the top of a 20-foot pole. That number is never going to change, right? So let's go ahead and write our 20 there. The height of the person is 5 feet. That's not going to change, presumably. Oops, 5 feet. Okay. Walks away from the pole with a speed of 5 meters per second. Let's go ahead and see what we're needing here. How fast is the tip of the shadow moving when he's 30 feet from the pole? So here's the big question. Here's our shadow. How do you measure how fast the tip of the shadow is moving? Do you want to measure that against this position? Here's a hint. Remember that the person is walking, right? So is this position going to stay fixed? Nope. It's going to be moving. And so when we say we want to find how fast the tip of the shadow is moving, we want to interpret that. We want to measure that. So measure from something that's fixed. Okay, so our street light is fixed, and so therefore this would be a good way to measure the tip of the shadow, x of t. Our actual shadow is just this much, right? But the rate of change of this tip is going to be measured from the end of the building, or sorry, building. This is a light. Good. Okay. Now what else is changing here? What else is fixed? I think, now when you're saying that the man is walking away from the pole with a speed of 5 meters per second, that means that this is the variable, right? The distance from the man to the pole. Good. And so now, do I need a variable for the length of the shadow? You could put one in. However, you don't need to, right? Because this length is actually already determined by the variables that we have, right? So once you've chosen x and y as your two variables, then that forces this third thing to go ahead and say that that's going to be x minus y. Okay, if we need it. Good. Okay, so that is drawing our picture and labeling the quantities. Now let's see if we can find a relationship between x and y. So that'll give us our related rates. So go ahead and take a moment. I'll pause your video and think about what the relationship should be between x and y that will give you the related rates. Okay, are you back? So the shape of the two triangles was hopefully suggestive. Does that remind you of something? Does that remind you of similar triangles? And so the idea is that the ratio of small to big is going to be the same no matter which length you're looking at. So let's go ahead and write that down then. 5 is to 20. 5 is to 20 as what is to what? I think we see it must be x minus y is to x, right? Good. All right. So that means that looks like 5x is equal to 20 times x minus y, right? Which is 20x minus 20y. Good. Okay, so that means if we simplify this a little bit, let's see, maybe I'll subtract 5x from both sides, add 20y to both sides, right? And so therefore we have 20y, oops, sorry. Let's see if I can get it to write nicely. 20y is equal to 15x, right? Or let me go ahead and write it over here. X is equal to 20 over 15 times y. And let's go ahead and simplify that. So that's take out 5 from numerator and denominator, so that would be 4/3. Good. And there is my relationship. And now remember, x and y are functions of time. Right? Okay, and what we're asked to do is we want to find dx over dt when what? When he's 30 feet from the pole, so when y is equal to 30, and notice that dy over dt is 5, right? So when y equals 30, dy over dt equals 5. Good, so that's pretty straightforward to differentiate then. Dx over dt, we're just differentiating straight across. Oops, sorry about that. Dx over, geez, my pen is going crazy. Dx over dt is equal to 4/3 times dy over dt. So I don't really even need the y equals 30. So I just use the dy over dt as 5. So dx over dt equals 4 times 5 over 3. 20/3. And that is in feet per second. Feet per second. Very good. And that is it. Good. So we'll try another example in just a bit.